The objective of this demonstration is to show cymatics through two various examples, a recreation of the Chladni plate experiment and a demonstration of water under the effect of pure tones created by a sine wave, as well as the vibrations or bass of various types of music genre. This project is based off a trial that became the Chladni experiment. The Chladni experiment consisted of a violin bow rubbing against metal plates to create patterns due to differing wave frequencies. Since we did not have a violin bow to work with, we created our own version of the experiment in which we made a setup consisting of a 6.5-inch subwoofer with a 6.5-inch metal plate on top. Using this setup, we recreated Chladni's experiment in a more modern way while still keeping the process and the concept the same, and did this rather inexpensively, you could say. The physics displayed in both the water or oobleck and metal plate parts of our experiment uses the same concepts, and in both situations the medians experience forces from the sound waves in both vertical and horizontal directions. The vibrations cause both mediums to have standing waves, and the standing waves make it so that the wave patterns can be viewed via the experiment without the need of any special optical or imaging equipment. Although the physics involved in the metal plate and the water/oobleck are the same, the concepts differ slightly, so we will explain them both.
The demonstration also shows how water and oobleck react to multiple frequencies of sound waves and multiple types of music, varying from calm classical music to more intense rap and metal music. In this demonstration, both the water and the oobleck are placed directly on the subwoofer for the most accurate results. physics for the water in the oobleck are the same as with the metal plate, but instead of the patterns only appearing when the frequency of the tone is at resonance, the water and the oobleck both show patterns continuously. Both materials also have many different patterns that they can show based on different frequencies. The only downside to using the liquid materials instead of the metal plate are that the wave patterns change too quickly to be seen readily, and the pattern cannot be seen being created slowly and in detail like they can with the metal plate. Bass is the only tone in music that the water reacts to because it is the only pure tone. Also, since bass levels vary greatly between types of music, the patterns that appear will also have great variation.
The physics of both the metal plate's vibrations and its different patterns can be explained by superposition and resonance. The subwoofer needs to vibrate in order to produce sounds, so since the metal plate is attached to the top of the subwoofer, it vibrates at the same frequency as the subwoofer. As the subwoofer continues to vibrate, the wave that it creates travels through the whole plate. When the wave reaches the edge of the plate, it bounces back toward the center. Since the subwoofer is constantly creating new waves, the waves that return to the center from the edge of the plate interfere with the newly created waves to create a standing wave. One difference between the concept of the metal plate and the water/oobleck is that the patterns of the metal plate only appear when the plate is in resonance. This is because when the plate is not at resonance, there is no standing wave. So instead of showing a uniform pattern, the sound waves just scatter around the material on the plate and randomly distributed.
Both the phenomena in water and metal plates can be described and even modeled by partial differential equations. This specific partial differential equation is called the two-dimensional wave equation, which has complex solutions, and in other words, the solutions are equations which involve trigonometric functions as well as the function I. Um, these equations involve partial derivatives, which are just derivatives of one variable in the presence of other variables. And this math describes both Chladni plate's behavior as well as the water in oobleck's behavior. And apart from the partial differential equation, Chladni's plate behavior can also be described by Chladni's law, which only determines the amount of nodes and diameter nodes in the plate. This partial differential equation considers multiple variables, and the derivation of the equation shows the density of the medium as well as the certain spring behavior within each of the molecules inside that certain medium. Apart from that, the partial differential equation assumes that the certain medium is acting as a solid membrane rather than a liquid membrane, which could also allude to some error within the predictions. Um, if you account for that certain material, the two-dimensional wave equation could be manipulated in a way that will correctly model water's behavior, which is seen by adding the part of the equation which includes the cosine part, since now it has a certain variable c which describes the wave speed as well as the viscosity of the material as a function of time, of course. Um, Constants such as m and b describe the medium's nodes and diameter nodes, and the constant of c in Chladni's law describes the material itself, which is either the wave speed inside the material as well as how the material is made and how it reacts to vibrations. There's also another variable called p, which alludes to the shape of the material, whether it's not circular or if it's a square. In this case, since it's a circular plate, the value p will be 2 and the value c will also be around 2. Overall, the partial differential equation helps model the water's behavior and the oobleck's behavior completely accurate, assuming that the boundary conditions are the same as that of the material that the water is in. In this case, the water is in a circular material since it is directly on the plate, and this will need to the equation to be in polar form. In other words, polar coordinates and polar graphing in order to uh, correctly predict the water's behavior. In modeling software such as MATLABs, this could be done easily and basically doesn't require the boundaries to be set as a circular specifically because the same behavior will be seen in the graph and modeling itself. In other modeling softwares, this is a different case which should only be seen specifically by the person using that modeling software. In conclusion, the completely accurate predictions of water's behavior, the oobleck's behavior, and also the plate's behavior in certain frequency will require a higher level of math that is just not available and to the public at all and would require months and months of learning, if not weeks of learning, which is time that we did not have in this case. But we did have enough time to learn how to derive a partial differential equation and learn how to manipulate that certain partial differential equation so that could suit our certain needs and situations, such as the cloudy plate as well as the oobleck itself. And the following graph from Desmos should show the difference in a true partial differential equation explaining Chladni's pattern and the derived partial differential equation that we ourselves got.